How does a radio work? Before getting into the details of how radios work, it's important to have a firm understanding of waves, the electromagnetic spectrum, and more specifically, radio waves. Here's a standard sinusoidal wave. As shown, the amplitude is the distance from the baseline to a peak. The wavelength is the length from one peak to the next. The period is the time from one peak to the next. And frequency is simply 1 over the period. These characteristics are consistent in all waves, but have very different values as we move across the electromagnetic spectrum. As we see here, radio waves are on the very left end of the spectrum. This is because radio waves can have wavelengths up to 100 kilometers. In comparison, the wavelength of visible light ranges from 380 to 750 nanometers. So while radio waves surround us every day, we cannot hear or see them directly. So how does a radio actually work?
Here we have a transmitter. There are several elements that work together to generate radio waves that contain useful information, such as audio, video, or digital data. The first part of the transmitter is the power supply, which provides the necessary electrical power to operate the transmitter. Then, the oscillator creates alternating current at the frequency on which the transmitter will transmit. The modulator adds useful information to the carrier wave. The amplifier, as its name states, amplifies the modulated carrier wave to increase its power. And finally, the antenna converts the amplified signal into radio waves.
These radio waves are then captured by a receiver, which also has several elements working together. The antenna begins the process by capturing the radio waves. The waves are passed through to the radio frequency amplifier, which magnifies the weak signal. The tuner extracts the radio waves that are vibrating at the desired frequency. These waves are passed to the detector, which separates and sends the audio information to the audio amplifier. The audio amplifier boosts the weak signal to be played through the speaker.
We mentioned before that the modulator changes the form of the carrier wave. This change, or modulation, allows the message to travel over long distances and helps secure the signal from unwanted signal mixing. Modulation is generally done in two ways: amplitude modulation and frequency modulation, better known as AM and FM radio. In amplitude modulation, the strength or amplitude of the wave is changed in order to send the message. With FM radio, the carrier's signal frequency is the only thing that is changed, hence the name frequency modulation. FM radio works at a much higher frequency, consumes more power, and has much better signal quality than AM because FM receivers filter out noise interference better than AM receivers do.
One way to create a radio wave using simple tools is to rapidly connect and disconnect a 1.5 volt battery to a voltmeter. This will create a changing electric current as the potential in the circuit goes back and forth from 1.5 volts to 0 volts. As you do this, you will be creating a square wave. You will need a battery, alligator clips, and a cheap voltmeter to read the changing potential.